All right. Hey, folks. This is Evans from Replicated. I'm a CRE at Replicated. And some of the things that we do whilst at Replicated involve working with our vendors and ISVs, to be specific, and in extension, their customers. We help troubleshoot and install failures, troubleshoot their degrading applications, misconfigurations, and what have you. Now, whilst at this role, we get to see all sorts of customer environments and configurations. They differ tremendously. You get to see various very secure, hardened environments, some of them very wide open. Now, in this talk about how to better prepare for installs to hopefully reduce install failures. Now, we know that installing enterprise software in such environment is hard. It's full of unwanted surprises, and usually nothing goes to script. You plan and you show up on the D-Day, things go wrong. Now, this leads to sales engineers getting frustrated, customers losing confidence. And this is not just an anecdote. There's a report that Mark just mentioned that was sent to some of our users and customers. And as you can see here, this is one of such a survey question that was raised on how vendors think their install experience is. 1 in 8 vendors think they deliver a delightful install experience. That is nowhere close to a good statistic at all. There's a lot of room for improvement there. Another question that was raised was how much time an install would take. Now, I'd want to think 30 minutes are long enough. It's good enough for a piece of software to be installed to a point where a customer can start consuming it. But that's not the case. It's far from that. 20% of customers claim that their installs go beyond the 30-minute mark. Again, lots of room for improvement. Here's another statistic here where they talk about having installs take more than weeks, many hours, many days, at times months. Again, it's not exactly what you'd think things to go when it comes to installing. Now, this is a typical multi-day install. You show up, you have your customer, your sales engineer is there, you're all happy, start the install, realize that you probably have the wrong airgap bundle. That's 1 day gone. Day 2, you're battling an antivirus software that's just making your day really bad. A 3rd day, you have another surprise of Ansible that is running, there's a cron or some scheduled Ansible task that keeps reverting all sorts of configurations that you have in your embedded cluster. Again, not a good day for an install. What do we have when it comes to some of these installation blockers? Before we go to the recommendations, I'll just mention a few of those installation blockers that we've seen whilst at support and calls with customers. One, and this one I'd say is at the top of my list. Now, the list that I have here is in no particular order, but this particular one gives me most headache, is security tools. Now, security tools, we have to live with them. You'll find them in all sorts of environments, but they cause failures in the most bizarre way. They cause an install to fail, or in a way that will throw you off the rails completely. Your network configuration will be all misconfigured. We've seen Illumio prevent IP table modifications. Obviously, you start looking at all sorts of network configurations in your system, trying to figure out why is traffic failing. Microsoft Defender, it just nukes processes left, right, and center. That throws you off completely. You have no clue what's happening. Now, troubleshooting is one side of this. You've spent hours, probably days. That keen eye might figure out, hey, there's a security tool here. Getting the right people to configure and make sure that this system works as should is the other side of the coin. That exacerbates the problem. The other issue here is misconfiguration of infrastructure. Now, we know the application installer is usually not the same person who does the provisioning infrastructure, especially in large organizations. Some of these teams are in different departments. At times, they've been outsourced. Now, if you show up on D-Day and all of a sudden the load balancer isn't configured correctly, that's a day gone. You don't have sufficient disk space, that's a few days gone, probably a week, depending on how the process of provisioning new hardware is. Another common installation problem we have here is automation tools such as Ansible. Now, you don't see this every day. Sometimes these tools would be installed in such a way that you wouldn't figure out that they're in a system for them to be caught, say, by a preflight. Say, Ansible just SSHs into VMs and reconfigures your VM depending on what rules it has defined. You wouldn't tell that it would be running. Now, these tools, if they run, they can throw you off the rails again. Sometimes they even lead to self-doubt. You're there, you've done your configurations correctly. All of a sudden, magically, for lack of a better word, your configurations get reverted. Again, this is another problem. Getting the right people on board is also a time waster to your install. So what are the recommendations that we have? First is having focused prerequisite guidance. When you write your recommendations, when you write your documentation so that your customers can consume, sometimes you end up putting on everything into that documentation. Now that can be overwhelming. There are multiple pages or things that the user application installer needs to sift through as they figure out, what do I need to do? We recommend focusing your guidance depending on the role that is going to execute certain commands. Now, your sysadmin does not necessarily need to know how to configure a sysadmin does not necessarily need to know how to configure the vendor's application, so your application in the customer's environment. On the other hand, your application installer does not really need to understand, or they may need to understand, but they have no responsibility or even the permissions to, say, install CRDs or provision VMs that are properly spec'd. They may ask for them, but they probably wouldn't be able to, do all that work. So being able to have forecast, perhaps even separating your documentation when you're delivering to your customer, goes a long way, because then your sysadmin, your application installer, and any other stakeholder does what they need to do and are able to focus on doing their part and delivering without mistakes. The other recommendation we have is codifying prerequisites. Now, we recommend using preflights. Reason is you get to have one standard way of verifying that your prerequisites have been fulfilled. When a user in this case, your customer or the application installer or the sysadmin, when they go through a list of recommendations of prerequisites, they run bespoke commands. Sometimes they come up with their own ways of verifying that they've fulfilled a certain recommendation. Now that can differ. That can be error prone as well. And all you get as a vendor is, yes, I did what you asked me to. On the day, when you're about to install your application, you'd realize that your spec'd VM isn't spec'd in the right way. They probably have multiple desks that are small, or maybe the network configuration is not configured properly. The load balancer isn't the correct one. There are all sorts of things that they might end up doing, but not verified correctly would end up causing delays during the install. Now, what we recommend is using preflights. You provide preflights that codify verifying all those requirements. If it's disk checks, you'd ensure that those preflights are run and your customer is happy. Now, what they get an experience of traffic light kind of experience. They get results and then they see, yes, all these checks are green. Some checks would be amber, some checks would be red, and they'd work through that. Now, there are some checks that can't necessarily be done, which we'll talk about in the next slide. Again, these preflights, You can provide your own custom preflights. Here we've seen, can see how to run preflights in an embedded cluster environment, Helm installs, and your sales engineer can essentially craft their own preflight spec, which is very customized to a specific deliverable that they have, a specific customer environment that they have. They don't necessarily need to rely on waiting for preflights being part of the product. They're decoupled from the product cycle. That enables them to be able to do their work efficiently, be able to deliver that installation on time and within the time period that they have planned. Here's an example of a preflight check. So this is one that checks security tools that we have seen interfere with installs. At the end of the talk, you'll get to see it. You'll get to see a link of this preflight, which we've hosted in GitHub. These preflights, these tools we've seen interfere with installs. However, security preflights, we do not have a way of accurately claiming that security preflight, that an environment with an antivirus software would work in a containerized environment. What we have with this preflight specifically is a way to detect that you have security tools involved in an environment and create that opportunity to have a conversation with the InfoSec team. Your application installer would run this and say, hey, I do see Microsoft Defender here. I do see Domio. I do see Symantec. I see a security tool in my environment. That conversation with the InfoSec team would lead to either checking, ensuring that tool is configured to work within an environment with container workloads, or either decide to have a separate kind of environment depending on the review process. So it creates that opportunity to have that conversation rather than being accurate. This is one of such an example preflight where that we would say would warn users from continuing with an install. Again, here's a pod limits verification preflight. Now, this is just an example to show you how you would write a preflight check that would work with an existing cluster. The other recommendation we have is requiring evidence-based validation. What we mean by this? What we mean here is you need to require your preflights run and a preflight bundle, which would have the results that the user would have seen presented to you. Essentially, you'd use this as a gating mechanism. Before installation day, you'd need to require that all preflights are green, and certain preflights, for example, the one we talked about, where you're checking for existence of security tools, there would be evidence that preflight or that requirement has been discussed and you're happy to continue with it. This helps you prepare on the day of install. It gives you that confidence, both the customer, since they've seen the results, and you as a vendor, and to be able to prepare for that install on that D-Day. Here, we talk about building that feedback loop. Again, you've collected preflights, you've collected all sorts of knowledge, because you've collected a lot of knowledge and experience whilst installing and seeing various failures. But you want to feedback that knowledge back to either product, or if certain preflights or preflight checks do not belong into a product, they can end up in a centralized catalog, so that other sales engineers, support staff, and what have you don't end up hitting the same problems with your customers. Finally, there are some aspects that you cannot codify as preflights. Now, some of these requirements are organizational in nature. So providing access control, configuring certain network setups, provisioning, ensuring that you have your proxies configured properly. So things like this are very organizational in nature. Like you want to have those documented elsewhere and captured in a way that can be consumed by your users. For this, we recommend using Enterprise Portal whenever possible. Enterprise Portal gives the ability to document your requirements based on an installation type. Now, here's an example where we have Helm install. Above there, you can see Linux as well. So you can have completely different documentation prerequisites for your install type, which is Linux. And with this, you're able to customize your instructions so that your users would use the same interface that they would use to download and progress with their installs. As you can see there, it's very progressive. There's the first part, which is your prerequisites, and then there's a second step, which is your installation step. And there's that continuation all the way to post-installation requirements. Again, I'd like to highlight that Enterprise Portal is heavily, especially this feature of customizing documentation is heavily under development. So watch this space for any new development. Finally, we've talked about being able to provide forecast prerequisites as documentation, utilizing preflights, expecting evidence from those preflights, and documenting what can't be codified. I hope you enjoyed this talk.
Thanks, Evans. It was really good to talk about that. Evan spends a lot of time at Replicated helping customers prepare for these deployments and supporting them when something doesn't go very well. So a lot of hands-on experience here. And I think that's really good advice to kind of take a step back and really think through that process of what it's going to be like in order to get that install to be successful, increase the odds and the likelihood of that install to be successful on the first attempt. It was really good. Thank you for that.